Good afternoon. It is 4 p.m. in Singapore and 9 a.m. in London. Welcome to the Asian Banker Radio Finance, the online broadcast platform that aims to enhance the understanding of industry by bringing together senior opinion leaders to examine current critical issues. This comprises an incisive 30 minutes panel discussion with a short question and answer segment in which our called-in audience can participate in. Today, we have with us our panel expert on banking technology, Ajit Kanagasundram, who built the global cards processing capability for Citibank and spent over 2 decades at the bank before retiring as the managing director of cards and banking applications. Thereafter, he also worked with DBS Bank as MD for consumer bank technology till 2009. Now, to share more about his experience and achievements at Citibank set up a regional processing hub in Southeast Asia in the 90s, and this was initially focused on Southeast Asian countries, but by 1996, the hub started serving all of Asia, then Japan and Australia were eventually added, and by late 90s, it was extended to Europe and Latin America, covering 38 countries. This was one of the notable projects of this scale of global processing, and entire development was built and headed by Ajit Kanagasundram. Ajit has actually shared details about his experience with different technology implementations at Citibank in his memoirs, part of which have been published as a series of articles on our website. These reveal his insights into the people, processes, and decisions made over the years that provide considerable lessons for generations to come. The pace of technology development actually is quite rapid as banks increasingly seek integrated systems for agile, faster processing capabilities, and flexibility to meet the demands for new age customers, that too at a lower cost. The industry is moving towards rapid digitization, open banking enabled by APIs, and cloud computing environment. Now, in today's Radio Finance session, we will discuss the following based on Ajit's experience: managing the challenges and critical success factors in implementation of a global project. In the current changing technology environment, we will discuss the relevance of mainframe as a reliable transaction processing hardware and how it can be integrated with the open systems. And what are the factors that heads of technology need to consider when assessing and choosing the technology that will fit their organization? Now, before I start the discussion with Ajit, let me share some information on how you can participate in this Radio Finance session. To ask a question, you can write your question into the chat box at the bottom right corner of the WebEx screen. Okay, good afternoon, Ajit, and welcome to the session.
Afternoon, Niti.
Great. So, Ajit, you have implemented global cards processing from Singapore and, as explained, for as many as 38 countries. And this was quite a notable...
Actually, can I interrupt? It's actually 28 countries. I don't know where the typo came from.
Okay.
But anyway, it was still the widest deployed card system.
Okay, so even 28 countries, that's huge. So, and this was one of the few notable centralized processing units of that scale, if I understand correctly?
I don't think anyone else has done that. And it came about, there was no grand plan to do the whole world out of Singapore. We first did the ASEAN countries, Southeast Asia, then North Asia, there's Taiwan, Hong Kong wanted to join, Korea, and then Japan, which is the first time any Japanese institution was processed offshore, because the Bank of Japan has very strict rules on security and reliability. Australia, then of course Middle East, and the final phase was Western Europe and Latin America, which, as you correctly stated, started in 1999, but we only finished it by 2003.
Okay. And Ajit, we would like to understand from you, what were the biggest challenges you faced during this implementation? It was actually quite vast, spanning across the countries over the globe. And what can the bankers today learn from your experience?
Well, let me tell you what we had. First of all, from the very beginning, this project was well funded. There was no question of cutting corners because the head of the bank at that time, a person called Rana Talwar, believed that technology would give Citi a competitive edge, right? So we were able to invest the way we wanted to in both the hardware and, more important, the people. The second reason why this worked was that New York had invested in a global telecommunications network called the GTN. It was the second company after IBM to do this, using very high bandwidth fiber optics. So when we decided, for example, to do Middle East or Western Europe or Latin America, the businesses did not have to invest in telecommunications. It was just plug and play because the telecom connectivity was also there. The most important factor, however, was that I was able to build a team in 1989, hand-selected, who stayed with this particular application until I left 15 years later. Now, this is important because when you accrue experience, both technical as well as business knowledge, things get done much faster and much better. So I would say these are the 4 success factors.
Okay, great. So, and with regards to meeting the unique country-specific requirements, because obviously, I mean, if it's spanning across 28 countries, there are different interfaces, there are unique requirements. So how did you manage that, and that too keeping the costs down while doing that?
Right. First, let me address the question of cost. The cost per card, both computer processing as well as application development, we used to aggregate it and divide by the number of cards, came down from about 850 down to 3 at the time I left. This is a factor of better efficiency and, of course, increasing volume of cards.
So how did you meet the unique country-specific requirements or interfaces?
So that's a very good question because, you see, the way we did it was we had region-specific code base. For example, North Asia, Japan, Taiwan, China, Korea, right, which were double bytes were on one code base. Then Southeast Asia, then the Middle East, Western Europe, Latin America, like that. So we had about 6 code bases. Then within each country, we would have a country-specific code. This is a very important point because after we did this project, Citi went into a project which I hope we'll talk to, where they tried to come up with a single code base across all businesses, and they failed. This is not intuitively obvious. You can get all the advantages of having a common code base by being, say, 90% common. You don't have to, that last 10% will kill you. It will kill you in terms of complexity. It will kill you in terms of regression testing. Imagine you have the whole world on one base and UAE has to make a small change. Everybody has to test it. So we were sensible. We had 5, 6 countries in a code base, and then within that, very small individual changes. With the modern tools of library management and all that, it's possible. It's not rocket science. So this is one of the important lessons because, higher management who don't know the details think, if 6 code bases reduces your cost by, say, so many %, why not go for one code base? That is a very dangerous step.
Okay, so interesting. So you can have multiple code bases have a larger amount of standardization across code, across these codes. Yeah.
It's got to be on the same hardware platform, the same operating systems, and the same vendor application code base, the same enhancement you have. As I said, region and country-specific changes.
And you also, when you were mentioning about another project at Citibank, I'm sure you're referring to the global Go-to Common project, so which I remember reading about costed something around 1.4 billion, but it was later shut down after 5 years of increasing complexity and escalating costs and delays. So what was the real reason behind this failure? And then
there are a number of reasons. There are a number of reasons. You see, if you want everybody on a single instance of a code base, That means everybody's minute changes have to be there. So let me repeat myself. The code becomes more complex because you have to have special subroutines for each country. For example, if, and this is a fact, in Latin America, Colombia has a very peculiar way of calculating interest. It's called mora interest. Other countries don't want it. Why give them that overhead, right? Because the computer program still has to go, okay, this subroutine is not for this country. So there is some cycles wasted there. Secondly, span of control. You have to get requirements from 28 countries. You have 3 releases a year. Not everything can go into each release. So now 28 countries have to agree what has to go in. Whereas if you have 6 countries or 4 countries, that's much easier. The next one is regression testing. If you have everyone on one code base, you make one small change for one minor country. Everyone has to test it to say that, ensure that they are not affected. This is not only a technology requirement, it's an audit requirement to show that every change is tested. You are wasting an enormous amount of time. What I'm saying is use common sense here, have regional code bases, not a single code base. Now, this does not prevent you from rolling out changes quickly. I'll give you an example. In 2001, we came out with a new application called FUSE, Fraud Early Warning System, right? And we rolled it out across Asia, Middle East, Europe, Latin America within 2 weeks. You don't want to get faster than that, right? And the only time limiting factor was for people to test it, to make sure it was okay. So this does not prevent you from rolling out products quickly, and neither does it prevent cost falling. In fact, the other way, if you try to do one, the cost will escalate.
Okay. So the biggest factor being, of course, not having a single code, having more like regional codes or a
Yes.
few regional codes and then kind of managing it from there. And,
right. And the code is about 85-90% standard in any case, right? So it's not very different. You know what I mean?
Got it. Okay. That's interesting. So that's a mantra that will apply for most of the global projects, I would assume.
Absolutely.
Now, that brings me to one other part, which is that the technology development, as you know, is very rapid. And we are seeing systems move from mainframe to open to clouds, the variety of banks looking for lower cost, higher efficiency, agility in their system requirements. Now, you've been an advocate for mainframe technology, which was also used at Citibank, yet we see some banks now shifting towards open systems. So I'm trying to understand what is the advantage of one system over the other, and what type of system would work best for what type of bank?
All right. The first thing is, it's not one fits all. You will have a mix of systems. Now, during most of my professional career, for large applications, the mainframe was the only game in town. And today, we must remember, it's a 50-year-old technology. IBM introduced the 360 way back in 1967, so it's 51 years old. So, is it still relevant? Let us take Singapore. In Singapore, Citibank, Hong Kong Bank, and DBS, their card applications is on the mainframe. Standard Chartered, UOB, and OUB have outsourced their card processing to a French company called Atos Origin, which is running it on a mainframe. So in Singapore, you have 100% of banks. I'm talking about card application. Now, why cards? Because it is a very transaction processing intense application. The number of transactions, say, during the day will double, triple in the evening. The number of transactions on an average day may go up by 15, 20 times on the days before Chinese New Year or Christmas. So you want to have a machine that is capable of running huge volumes of transactions. And as far as I see, this is the mainframe, even now. Because if you look at all the main banks in the UK and the US, that's still the case. India may be an exception, but all the big banks in the UK, US, 100% of the banks in Singapore, for their credit card transaction processing. That is interest calculation, authorization, etc. Statement generation are on the mainframe. Now, why is this? Because the cost per transaction, especially if you have a high volume application, you have to take everything into account. The cost of adding extra security, all that, the mainframe still comes out cheaper. Let me give you an example. 5 years ago, the Korean banks, right, they have a common processing center. They moved to open platforms. I won't mention which software, but open platform. Now, they found that at very high transaction volumes, nothing broke down, but a few transactions were missing. Now, you can't have this in a financial system. You have to have 100% reliability 100% of the time. So what they spent a long time, about 6 months investigating it, then they went back to the mainframe. Because remember, 50-year-old hardware, the software which is called OS 390 and CICS has been tested so much by so many people, all the bugs are out now. So it works. But the mainframe is not suitable for things like the new internet banking where you need fancy graphics. You don't use it for mobile banking. So these will coexist. Now in Citibank, mobile banking and internet platforms are open systems connected via APIs to the mainframe, which keeps the financial records of the bank. It works quite well, right? You need smart people to do the interfaces and make sure everything works well, but it works. The second reason why the mainframe should keep the financial records of the bank and the posting to your financial ledger is security. Now, there are different levels of security, but what IBM uses is something called RACF, R-A-C-F, which is the only commercial security which has the highest U.S. Defense Department rating. In addition, 2 weeks ago, IBM announced that in their Z series, which is their mainframe, they are going to implement security at the bit level using hardware encryption, which makes it almost impossible to break. Now, we read all the time, PayPal has been hacked, Uber has been hacked. I bet they're not on IBM mainframes because they're on open systems, which are much more user-friendly in many ways, but they have this problem that you can't secure them 100%. So, as I said, while mainframe is not the answer to everything, it will be a long time before banks move away from IBM mainframe. By the way, IBM is the only game in town today, and that's one of the negatives. Because of security, scalability, and the fact that you can be absolutely sure of transaction integrity. Now, the downside is you're tied to one vendor. Up to 15 years ago, the Japanese, Hitachi and Fujitsu, were making compatible mainframes, but they dropped out of the business when IBM introduced the CMOS processor. So today, IBM is the only supplier of hardware and software if you're on the mainframe, right? If you're on the IBM mainframe. So many managements correctly regard this as a downside because IBM has also all the pricing power. And this is an issue which is a matter of concern for me as well. But there are restraints on IBM. One is the U.S. government, anti-monopoly laws. They can, if they're too predatory in their pricing, they will suffer there. And the next thing is, if they are too extreme in their pricing, people, despite the disadvantages, will move out. And once you move out, you'll never come back because the cost of doing that is too high.
Okay, so quite interesting and quite insightful actually that way. It explains a lot of things in detail. So you would say that for core transaction processing, you would say mainframe is better, but for internet, mobile, and the other front-end applications, one should look for open banking systems. So would that be the way to go?
Yeah. For example, say you take an internet banking app. You have lovely graphics, radio buttons, all that kind of stuff. You don't do that on the mainframe, far too expensive. You do it on an open platform. But when it comes to the customer saying, show me my balance in this account, he'll go to the mainframe through an API, fetch the information and display it nice. So these are coexisting applications. right? This is not something I invented. This happened through normal evolution, and this is what is happening in most banks.
And there are no issues in kind of developing interfaces or integration of mainframe systems with new system applications. So how can banks achieve that?
No, there are standard protocols you can use. Only thing is, as I said right at the start, you need smart people to do it. It's not because you need to make sure that everything is in sync, right? For example, if a customer is looking at his account and meanwhile there's been a credit from somewhere else, when do you update it? How do you update it, right? So there are lots of issues like this, but, you know, smart people can resolve them.
Okay. Yeah, it always boils down to people, process, and technology at the end of the day.
Absolutely.
Okay. So, and after Citibank, you were with DBS Bank, and I guess your experience there would have been different because they have different kind of systems. So, of course, even their core banking system is on a different system, not a mainframe. Now, why don't you share with us? Sorry,
their core banking is still on a mainframe, right? I'll tell you, it's a very interesting story.
Okay.
When I joined, their core banking was on the mainframe. It was actually written, surprisingly, by Port of Singapore Authority in the 1970s. They still had it. And Hong Kong DBS was on a thing called Systematic, which is what Citibank used. Their cards, they were using the same platform, Vision Plus. They decided to move not the cards, but the banking to the Infosys system, right, called Finacle. They got Accenture, the most expensive technology project manager, right, to do the transition. They started the project actually the year before I joined. When I left 3 years later, the project was still going on. A year after I left, they canceled the project, writing off 500 million Singapore dollars. Right? Now, again, they made the same mistake. They wanted Hong Kong, Singapore, Indonesia, and India on a single code base, right? For the 3 years I was there, they were still collecting requirements, and requirements keep changing. And if Hong Kong has one requirement and Singapore has another, it's not a question of saying we'll put both. You have to arbitrate which one is a better way of doing things. Singapore Bank's the biggest financial disaster. It's not as big as the Citibank one, but it's still pretty big. Now, they are still doing it. They are trying to move to Finacle, but they're doing it in-house. They're doing it small module at a time, and eventually they will move mainframe, first Hong Kong and then Singapore, from their existing mainframe apps to Finacle. Infosys was not responsible for this because they only did the coding, and they did it quite well. It was the concept and the execution that was at fault.
Okay, that's interesting. So, you also mentioned about Accenture being involved in the project, so and outsourcing of systems. So, in Citibank, as you mentioned before, there was a lot of in-house development, and there is a lot of outsourcing of systems at DBS Bank. What are the considerations here, and what do the bankers need to keep in mind in an in-house versus an outsourced system environment?
You see, it's a very interesting question. First, to develop an in-house capability requires years, right? You need to have a team which is not only technically good, but to understand banking, etc. And technologies are not easy to manage, they're temperamental, all kinds of stuff. But once you have it, you can do so much more because they're so much more productive than outsourcing. If you outsource, it's a one-way street. If you lose your IP, you lose your people, it'll take you 5 years to rebuild it. So many banks, when it was fashionable 10, 15 years ago, went into outsourcing. All of them regretted it. JP Morgan Chase in US outsourced everything to IBM. When the current chairman, Jamie Dimon, came in, one of the first things he did was to take it back. It was not an easy process. In Citibank, we were fortunate. We had top management support from way back, and we were able to build up a team, pay them sufficiently to retain them, right? And that was a huge advantage for us. Of course, you can misuse this as they did with the global go-to-common and give them the impossible task of a single code base. But if you use them properly, they're extremely effective. I am personally against complete outsourcing. You can outsource coding. For example, if you have the expertise to do the design and the testing, fine. The coding can be outsourced. Not all of it, most of it. But you should not use your intellectual property to be able to design and code. Also, technology does not stand alone. There is a huge amount of interaction between the business and technology. Now, for example, if you are outsourced and you're dealing with a vendor, you give him a set of requirements. His lawyer, your lawyer looks at it, you sign so many agreements, and they go off and develop it. It might take them 6 months, 1 year to deliver it. Meanwhile, conditions in the market change. Your guys want to make a change. You have to go through lots of processes to change it. Whereas if it's in-house, it's a phone call. Hey, I don't want this reward system like this. I want it like this. Quickly do a prototype and let me see what it is like. You can't do that with a vendor. Every time you do something with him, it's a legal contract, right? And the number of outsourcing contracts that have ended up in courts, you won't believe it, especially in the U.S. So my advice to bankers is keep your technology, the core team together and keep it in-house.
And what about the cost in this scenario? Isn't that a substantial burden in terms of having a ready pool of resource?
Yeah, if you look at the cost per head, is much higher. But if you look at the total cost of a project, I mean, it'll change from project to project, but it's cheaper. We did the global cards project for under 50 million US, right? I mean, it's a mistake to just look and say, okay, in India or China, the cost per head is $5,000. In Singapore, is $15,000. Therefore, China or India must be cheaper. No, you have to look at the total cost of the project. So I'm convinced it's cheaper to do it in-house with some of the coding outsourced. Yeah, the coding can be outsourced, no problem.
Coming to my last question. So now, as we see the pace of technology development, so there is requirement of a strong integration between systems, and as you mentioned, again, between multiple vendors also, and the bank with the vendor. Now, banks are moving more towards like open banking, API kind of an environment, and there is a coexistence of legacy with new technology in an integrated environment. So now in this environment, what would be your advice to current heads of technology, especially with regards to technology architecture, how they can define it for keeping the future in mind?
Technology architecture for banks. My first advice is keep it simple. Technology architects are usually very prone to having very complex models, which when you try to implement it, cause you lots of problems. So main thing is to keep it simple. The second thing is in an open. You see, even IBM, which resisted this for a long time, is now making its systems compatible with certain open architecture principles, which are really determined by industry groups, not by any particular vendor. So they have to in order to play in the new game, right? So this is really a good time. I mean, in the sense that in the past, 20 years ago, if you were with IBM, very difficult to integrate with anything else, but that's not the case anymore. Even IBM subscribes to the open interfaces. They even run operating systems like Linux on their mainframe. And Linux is not IBM, so you get it for free. This is the way things are moving, and I think it's a very positive thing.
Okay, great. So let me just concisely summarize what we've discussed, and that there were quite a few of insights that came out. So of course, one is that when you were building a common architecture or a technology platform, there needs to be a reasonable amount of standardization. So kind of keep the interfaces standard and have common coding to a certain extent, but not have a single code. So maybe have regional codes, which could make it easier for launch of global projects, definitely. The other thing we talked about was with regards to mainframe being much more scalable, and especially for high volume of transactions, reliability and security, ensuring transaction integrity, but towards meeting the new requirements of internet, mobile banking, the fact that they are tying to one single vendor and there is need for coexistence of systems today. We need to identify what system works best for which type of system, so depending on the individual requirements. So and possibly for the core transaction processing mainframes as you recommended, while for systems like internet and mobile banking, look for more open systems. The other thing we discussed was keeping the architecture simple, open, having open interfaces, and of course keeping in mind the people skill set required for the projects, which could be a very critical factor in the eventual success of your project, especially if it can be in-house developed project like you described the project that was done at Citibank. So I think we covered quite a lot of ground in today's session, and I have to thank you, Ajit, for your insights for the session today, and I have to thank the audience for calling in for the session today. We hope that you found today's session insightful and useful. If you have missed any part of the session, a recording of this will be available on the Asian Banker website. So do visit the website, and you would like to listen to, if you want to listen to the playback of the session. So until the next event, we wish you all a very good day. And thank you again, Ajit.